morning. In this video, we are going to see some more previous year questions of AFCAT EKT examination, that is Engineering Knowledge Test examination. So this is a preparation for AFCAT EKT examination. Okay, so in this video, we are going to learn some more new concepts. Okay, so let us see what is the first question. As compared to closed loop system, open loop system is dash. A, more stable and accurate. B, more stable, less accurate. C, less stable, less accurate. D, none of this. Okay, so what is actually an open loop system and a closed loop system? Open loop system, so these are two type of control systems. Open loop system means it is having, there is a system here, there are certain applied inputs and we will get certain outputs. Okay, so this is a open loop system. Whereas in a closed loop system, this system is having a feedback. Now, why this feedback is being added to this? That is an open loop system with a feedback is called closed loop system, right? So, in the closed loop system, why we are actually adding the feedback is to avoid errors or fluctuations in the input side. If any fluctuations or errors is happening in the input side, in order to correct, we are adding a feedback. This feedback can be either negative or positive. So, this feedback is actually ensuring more accuracy of the system. So, closed loop systems are more accurate. Whereas, considering the case of stability, open loop systems are more stable. Due to this presence of this feedback itself, this closed loop systems are not very stable. Okay, so open loop systems are more stable, whereas accuracy is more for closed loop system. So this thing you should understand. Okay, so the correct answer here is, we are going to, as compared to closed loop system, we are going to talk about open loop system. They are more stable but less accurate. Why the accuracy is minimum? Because of the absence of feedback. So when we add feedback, it increases the accuracy of the system. Okay, correct answer is option B here. Next question. A radioactive isotope has a half-life of 10 days. If today it is 125 gram, that is 125 gram of it is left, then original weight 40 days earlier is dash. A 600 gram, B 1000 gram, C 1250 gram, D 2000 gram. Okay, so before going into the question, let us discuss briefly about half-life. So radioactive isotope, we know that this radioactive isotope is some materials or some substance which is capable of emitting radioactive radiations, alpha, gamma, beta. These are various type of radioactive radiations. So these radioactive isotope, they disintegrate. That means the material, by emitting the radiation, they disintegrate. And this is generally expressed with the help of half-life period. Okay, so if you are not aware of the concept, please do have a closer look. Half-life period. So half-life period means, say if X gram, if representing in grams, consider X gram of the radioactive isotope is present, then with a particular period, let T, it is going to disintegrate to half of its value, that is X by 2 grams it will be. That is, X has become X by 2 grams. It has disintegrated by emitting of radioactive radiations. It has disintegrated to half the value. And the time taken is called T, and this time T is called half-life period. Let us now discuss or go into the definitions. I hope you have understood the concept. X to X by 2 has changed. That is, half the value has been disintegrated. And this time period is called half-life period. Okay, now in the question, let us move on to the question now. So in the question, it is been given that 10 days is the half-life period of any of the radioactive isotope. The name is not given. Okay, so now, that is presently, there is 125 grams. And they are asking how much of the radioactive isotope was present 40 days earlier. Okay, so consider that presently it is 125 grams. So it has disintegrated with certain period, that is 10 days. So every 10 days it is disintegrating, and after this 40 days, it is now 125. So what was the initial value? Let it be x. Let x be the initial value. So the x has disintegrated once and has become x by 2. Okay. Then it has disintegrated again and has become x by 2 into 1 by 2. That is half of this x by 2 means x by 4. Then again it disintegrated and has become x by 8. And then it disintegrated to x by 16 and has become 125 grams. Now consider, this is the case when there is 10 days here, there is 10 days here, then 10 days here, and then 10 days here. So totally 40 days has taken to disintegrate from x to x by 16. Okay, so it is being given. So consider that this is the present day we are talking. So this present day, it is 125 gram, and we need to find what is the value of 40 days earlier. This is how you draw this. So if you practice such type of question, you can do it by my calculation. Anyway, for the people who are new to this concept, I am just drawing it. So an x has disintegrated to half its value, again half its value, again half, and then half, and took 40 days. This one half-life period, second, third and fourth half-life period, it has become x by 16, and now, and that is a present day, it is 125 gram. We need to find the value of x. How will you find it? X by 16 is equal to 125 gram. So what is x? X is equal to 125 into 60. It is equal to 2000 grams. Is the initial amount or weight 40 days earlier. Okay, so correct answer is D, which is 2000 gram. I hope it is clear. Correct answer is option D. Next question is this. Hartley oscillator is dash. A, an inductively coupled oscillator. B, capacitor coupled oscillator. C, switchable for low frequencies. D, none of this. So a Hartley oscillator is an electronic oscillator in which the oscillating frequency is actually determined by a tuning circuit. And this tuning circuit is actually consisting of capacitors and inductors. So we can also call this Hartley oscillator as a LC oscillator. But if you ask, or if you say the tuning or the oscillating frequency is mainly determined with the help of a inductor in the tuning circuit. Okay, so it can be called as an inductively coupled oscillator. The importance is given to the inductor there. So the correct answer here is an inductively coupled oscillator, which is option A. Okay, next question. Binary value of 45 to the base of 10 is given in decimal is dash. So I have not written the options here because it can be directly answered. 45 to the base 10. So we are going to convert it to binary format. So dividing by 2, it is 22 remaining 1, 2, 11 remaining 0, 2, 5 remaining 1, 2, 2 remaining 1, 2, 1 remaining 0. The answer is 1, 0, 1, 1, 0, 1 to the base of 2. 1, 0 here. 1, 0, 1, 1, 0, 1. So this is how you can convert a decimal number to a binary number. Okay, this simply by dividing with 2. I hope that you know how to convert decimal to binary. Answer is 1, 0, 1, 1, 0, 1 to the base of 2. Next question. In MKS system, we measure dash. A, mass in kilogram. B, time in second. C, distance in meter. So this is actually a measuring unit. There is MKS and also there is CGS and there are various other types. So the two important ones are MKS and CGS. What is MKS? MKS and okay. So in MKS system, we measure M is meter, K is kilogram, S is second. Okay. So meter, kilogram, second. Mass in kilogram, correct. Time in second, correct. Distance in meter, correct. So that is the MKS system. The correct answer here is option D, which is all of this. Now, if the question was CGS, if it is CGS, then you have to change it as C is centimeter, G is gram, S is second. Okay, so if the question is for CGS, you have to answer centimeter, gram and second. Now what is one peculiarity I have seen in the AFCAT examination question paper is that they are not just concentrating on the electronics only. They are also asking questions from chemistry and physics. Some basic questions. The questions like this can come. Okay, so you should be aware of these type of questions. General things we study, that is we prepare for entrance examination for engineering or anything. So these basic things also you should know. So this is actually very common sense. You can study or you can write these type of questions from the memory. Okay, anyway, the correct answer here is option D, that is all of this. Okay. An ideal DC generator is one that has dash voltage regulation. A low, B high, C 0, D positive. An ideal DC generator doesn't having any voltage drop from inside to the load, or it doesn't has any voltage drop in general, and for an ideal DC generator there is zero voltage regulation. Correct answer is option C. Since it doesn't has any voltage drop, it doesn't require voltage regulation, so voltage regulation is considered to be zero. Option C is the correct answer. Next question, the unit of magnetic susceptibility is dash. So before going to the unit, the expression for magnetic susceptibility is, it is represented as X. It is the ratio of magnetization to magnetic field intensity. So if it is represented as in terms of Weber, the unit of this magnetic susceptibility is Weber per ampere meter is the unit. So what is magnetic susceptibility? It is a ratio of magnetization to magnetic field intensity. Answer is option B, which is Weber per ampere meter. Next question. A stator in induction motor is made of dash. So we know that an induction motor is consisting of a stator and a rotor. Okay, so this stator is made of dash material. A carbon, B wood, C copper, D silicon steel lamination. So if you have seen inside or in the inner structure of a induction motor, the stator is made of silicon steel laminations. Option D is the correct answer. I have next included an image of a induction motor's inner diagram, that is stator and rotor, just to make you familiar with this structure. Okay, so these are all theory questions. Correct answer here is option D is the correct answer. Here is this. A differentiator circuit has a dash. Question is regarding the time constant of the differentiator circuit. Next question is this. A differentiator circuit has a dash. A, very high time constant. B, infinite time constant. C, very low time constant. D, zero time constant. So what is actually a differentiator circuit? In differentiator circuit, the output is directly proportional to the rate of change of input. So this circuit is actually differentiating the change of input. Okay, so such a circuit is called a differentiator circuit. And the circuit with op-amp for a differentiator will look like this. There is an op-amp, there is a positive which is grounded. So this is a V-in. There is a resistor connected to the feedback loop. This is the output. Okay, so this is the differentiator circuit using a op-amp and the capacitor and resistor. Okay, so this circuit uses an op-amp. So here the rate of change of input is the output, or the output is directly proportional to the rate of change or the time variant of the value of your input. So here a small time constant is required for a differentiator circuit. That is, within the small time period, any small changes in input should be reflected in the output side. So the time constant is very, very low. or a low time constant is present for a differentiator circuit. Okay, so this is the differentiator. Now, if it was an integrator, there is a capacitor in the feedback loop. Okay, so we have discussed about the integrated circuit in earlier videos. I don't think for a AFCAT examination, but any of the previous year question videos, we have discussed that this is the integrator circuit. So there is a, if you see a capacitor in the feedback loop, you should be able to figure out that it is a integrator. And if it is a resistor in the feedback, it can be a differentiator. I'm not saying always differentiator, but it can be a differentiator. Okay, so if it was an integrator, means the capacitor will charge for the specific integration period. Then it will discharge. Okay, so now we are talking about differentiator. So it will be like this. This is the differentiator circuit and the time constant is very low. So correct answer is option C, which is very low time constant. So here the output is directly proportional to the rate of change or approximately proportional to the rate of change of input. Okay, next question. Commutator is used in dash. So commutator is a device used in DC machines, that is direct current DC machines. We are using a commutator, and the purpose of this commutator is to produce a steady rotating force which is called a torque. So commutator is used for producing a torque in DC machines. So they are used in DC generators and DC motors, not in AC machines. Here the question is commutator is used in dash. A, DC generator is the correct answer. B, AC generator, no, it is used in DC machines. Inverter, no, it is not used in inverter. And converter, no, it is also not used in converters. They are used specifically in DC machines such as DC generators and DC motors. Okay, so that is a commutator and the correct answer is option A. Next question. Next question is a very commonly seen question. Shannon's theorem set limit on the dash. So we are in a lot of previous videos, we were discussing about the Shannon's Hartley theorem. I have seen a lot of question papers with this question. So if you don't know about the Shannon's Hartley theorem, let me just give you a brief about it. Shannon's Hartley theorem is set or it is defined to set the capacity of your communication channel. And it is defined as C is equal to B into log 2 1 plus S by N. Okay, so this is your Shannon's Hartley theorem. Okay, or log 1 plus S by N you can write. Okay, now here C is the capacity of your communication channel. B is the bandwidth. Then S by N is the signal to noise ratio. Okay, now let us move on to the question once again. Shannon's theorem set limit on the dash. A, highest frequency that can be sent over channel. No, it is not talking about the frequency. Option B, maximum capacity of channel for given noise. Yes, that is the theorem. Correct answer is option B. C, maximum condensation. No. D, none of this. No. So this Shannon's Hartley theorem is defining that or saying that C is the maximum capacity possible for a communication channel without errors. That is, within the given error limit, this much of communication is possible. So when a data rate R is selecting, we have to select R such that R should be less than or equal to C. Always this rule has to be selected for the data rate R. Okay. So R should be less than or equal to the capacity. Maximum capacity possible is C. So the data rate should be less than the capacity. Correct answer here is option B. Which is a non-triggered multivibrator? So a non-triggered multivibrator means it doesn't have a trigger or an input signal. A, stable multivibrator? No. B, monostable multivibrator? No, it is having a triggering signal. C, unstable multivibrator. If you see, in an unstable multivibrator, two transistors are connected back to back. There is no triggering signal there. So the correct answer is C, which is stable multivibrator. Okay, I'll include the image of an stable multivibrator if you want. Okay, Okay, I'll include the image of a S-stable multivibrator. Then you can identify that it doesn't have a triggering signal. Correct answer here is option C. After firing the SCR, the gating pulse is removed. The current will dash. A immediately fall to 0. B increases. C increases and then decreases. D remains the same. So there are various methods of triggering of an SCR, that is silicon control rectifier. DVDT triggering, thermal triggering, gate triggering, time differential triggering. So there are various types, that is DVDT triggering. Okay, so these are the various type of triggering of the SCR that we have discussed in one of the previous videos. Here they are talking about the current. So what will happen if the the triggering signal is removed from the gate? The current will initially increase, but then it will decrease to the holding current, and then below the holding current, the device will get turned off automatically, that is by itself. So here the current will initially increase and then it will decrease. Correct answer is option C is the correct answer. Current will initially increase and then decrease. Next question. The bandwidth requirement of telephone channel is dash. A 3 kHz, B 10 kHz, C 5 kHz and D 15 kHz. So the bandwidth requirement of the voice channel of a telephone system. So we use voice channels for telephone system, right? The frequency requirement is 300 Hz to 3400 Hz. So if you take the difference, that is called bandwidth, right? High frequency minus lower frequency range in the spectrum. So it is 3100 Hz. Okay. So here you can write it as 3 kilohertz, right? So the bandwidth is 3 kilohertz, which is the correct answer here. Option A is the correct answer. Okay, so these are the questions which I have included in this video. We will be doing more videos for AFCAT preparation very soon, because the examination is going to happen very soon. So I hope that this video was useful for your preparation. If you are not also preparing for AFCAT, and if you are preparing for some other examination called ISRO Technical Assistant, or any of the examinations which is going to happen very soon, because there is a lot of requirement happening for the electronics field. So if you are preparing for any of this examination, these videos will be useful. And if these videos is useful for your preparation, please do give it a thumbs up and also share these videos with all your friends. And if you want more videos, please do subscribe to the channel. Thank you.